Hello everyone, this is R. Parthasarathi. I am working as an assistant professor in the Department of Civil Engineering in Hindustan College of Engineering Technology, Coimbatore. So today I am going to take one e-content that is related to Introduction to Structural Analysis. Let's we move to start the presentation. So the structural analysis, a structure is a system of force that is interconnected the members used to support the external loads. The structural analysis is the protection of response of structure to specified arbitrary external loads. During the preliminary structural design stages, the structure's potential external load is estimated. The size of the structure interconnected members are determined based upon the estimated loads. The structural analysis establishes the relationship between the structural members expected to external load and developed internal stresses and displacement that occur within the member of this in-service load. Thus necessary to ensure that the structural members satisfy the safety and serviceability and requirement of the local building code and also for the specifications to make whether the structure is located. So this is the major example definition and reason for why we study structural analysis for the buildings. So the first one, beam. Beam is a very important one element for framed structures in the construction activity. So in the beams are the structural members whose longitudinal dimensions are appreciably greater than the lateral dimension. For example, length of the beam as shown in figure significantly greater than the breadth and depth. So a cross section of the beam can be, sometimes we are using rectangular, circular, triangular, or it can be standard such a channel section, a T section, angle section, I section. So these are the examples for a steel section and previously example for the concrete reinforced sections. So in this picture already I defined that is length is always greater than breadth of the beam and depth of the beam. So in this next one, columns. So this is the second category of the major important part, the columns, a compression member in the construction activity. So columns are vertical structure members that are subjected to axial position, and also for they are referred to the strut and stanchions. Columns can be circular and square and rectangular and the cross section, and they can also be standard sections. In some engineering applications where a single member strength may not be adequate to sustain a given load build-up, the columns are used. A build-up column is composed two or more standard sections. So we are using different shape of sections like a square section, rectangular section, circular section, T section, L section, and cross sections. So the next one, the combination of column and a beam, that is called as a frames. So frames are structures composed of vertical and horizontal members. The vertical members are called columns and horizontal members are called as a beam. So the frames are again classified into sway frame and non-sway frame. A sway frame can allow to lateral side sway movement. Yes, it is possible to move side sway, but well, non-sway frame does not allow to movement any of the horizontal direction. So this is the sway and non-sway frame. The lateral movement of the sway frames are accounted for in their analysis. Frames can also be classified as a rigid and flexible frame. So a joints of a rigid frame are fixed, whether those are the flexible frame or the movable. So in this previous, the section is frames are joined rigid and fixed joint, and second one it is a flexible and pinned joint. So trusses, the combination of purlin and galvanized iron sheet and beams are called as truss member for making the industrial building. So in these trusses can be structural framework composed of straight members connected to at the joints as shown in below. The structural analysis stresses are applied in the joints and members are assumed to become connected at the joint using the frictionless pins. And also the next one, beams, columns, trusses. This is the best pictures, the example pictures for framed structure and industrial structure like a column and a beam and trusses are mentioned. So the fundamental concept of principles of a structural analysis. So in civil engineering activities, the structures are designed to at rest when acted upon the external forces. A structure at rest must satisfy the equilibrium conditions. So the equilibrium conditions are called as summation of forces are is equal to 0, summation of moment is equal to 0, summation of forces. So we have vertical forces and horizontal forces, definitely that forces are acted on the particular structure. So we can satisfy the structure along with the three equilibrium conditions. That means it is a determinate structure, stable. And the methods available for to analyze a structure, like one is a flexibility method, stiffness method, and finite element method, virtual work method, moment distribution method. So why we calculate bending moment? So in structural analysis, in framed structure or in any of the building, bending moment is a major role. Why we calculate the bending moment? Because of one practical example picture I mentioned in this slide. So one of the car is accidentally stuck with the lake. So for recovery process, we take a car particular lake from by using the recovery vehicle. The recovery vehicle is connected with the girder. So a vehicle is we can start our recovery process from the lake, and second, the lake car is near from the recovery station. Unfortunately, the car is failure. Okay, it with the recovery vehicle also, because of the bending moment is not properly calculated. Why the capacity of the vehicle and what is the capacity of the recovery vehicle? So this is the process main reason we have to give the maximum importance for bending moment and structural analysis concept. Thank you all. Thank you for watching this video.